Not right this minute though. So evaluate each infinite geometric series described. Okay, so first thing I do is I look here. The multiplier is 1/3. So will a sum exist? Yes, 1/3 is less than 1. So a sum exists. Okay, and the sum formula for infinite is first term over 1 minus r. And the first term is 7/6. And 1 minus 1/3. Okay, I'm going to show all my steps, 7, 6, and then I'm going to change this to 3/3 minus 1/3. The theme of the day is common denominator, so, this warm-up's like perfectly set up for me to get a common denominator. Okay, subtracting fractions, subtract across the top, bottom stays the same. Some people on the test just crossed it out. I thought that was fun. Keep, change, flip. Okay, and now because we're in the middle of rational expressions chapter, I'm going to cancel this diagonally because I can. So I see 3/6 reduces to 1/2, which gives me a final answer of 7/4. Any questions about number 5? Okay. Number 7, expand completely. This is binomial expansion. We're in row 3, and the coefficients of row 3 are 1, 3, 3, what? Do you know where I got this information from? Yeah, the 3 came from the exponent, and these numbers came from the chameleon. No, really. He's named after the mathematician. He's not the mathematician. But I do like the fact that Rapunzel is a scholar, that she would name her chameleon that. I think that's good. Anyway, okay. 1, front seat to the full power, back seat to the 0, plus 3, front seat down, back seat up, plus 3, front seat down, back seat up, plus 1, front seat down, back seat up. On the test, a lot of people had this written out really nicely, but they didn't take the number inside the parentheses to the exponent also, which is what I warned you was going to happen about 57 times, and yet it still happened. So, I don't know what to do there, but maybe you'll see that when you get your test back. So 1, 1, 1, 1, 1, 1. Cancel, 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 cancel. Okay. 2x cubed is 8x cubed. Plus, okay, I'm going to write this 2 times. So 3 times 4x squared times 4y plus 3 times 2x times 16y squared plus 64y cubed. Okay. 8x cubed plus 3 times 4 is 12 times 4 is 48. X squared y. 3 times 2 is 6 times 16 is 96, I believe. Anyone? Done. Trying to think, were we using anything else in the packet today? I don't think so. And I think the packet's done. Alrighty, let's look at the agenda. So we're doing 4 problems. They all have multiple parts. 26 is quick. None of the rest of them are quick. Oh, that's not true. 29 is actually quick. 26 and 29 are quick. 27, 28, absolutely not quick. Homework is 31 to 37, skip 36. And this says e to the fun. And then it says the water slide with the exponential drop off, 2.72 seconds of free fall. Do you get the 2.72 is E? Remember the video? 2.72 seconds. So maybe this isn't such a good idea. Yeah, it's it's that person there, it doesn't look like they're faring so well. Here, let's see if I can hold on. There we go. E to the fun, the water slide with the exponential drop off. And this dude here, I don't know if this is gonna end well. And this guy, I mean, he's getting out. That's a good thing. Okay, anyway. Okay. All right. We got some adding and subtracting fractions here. Today I'm going to use 2 colors again. I'm going to use the blue and the red pen in case you're a person who likes to decorate like I do. Okay, you guys. So start with this first one. So the point of number 26 is to remind you of fifth grade. Again, we concluded it was fifth yesterday, I believe. And to talk about what happens, what? What I learned it in fourth too, but I just wonder if it matters, like the teacher. I don't know. Anyway, okay. When you're adding and subtracting fractions, you need a common denominator. So that's the theme of the day is common denominators. And what you do is you add or subtract across the top. So 8 plus -3 is 5. And then the bottom stays the same. The bottom doesn't cancel or anything like some people did on their test for some reason. I don't even know. But, and it wasn't actually on the infinite geometric problem. It was on the Pythagorean identity problem. They're just like, it's gone now. I don't know. Anyway, okay, final answer. Okay, now I want to go down to C because C already has a common denominator. So we add across the top. Bottom stays the same. You have to resist the urge to cancel. This doesn't cancel. That does not reduce. You don't do that. 2 is being added to a number first in PEMDAS, then divided by 6. You can't do it. Okay, this guy, this is the whole reason we're here. This is it right here. This is the big moment. Okay, I don't have a common denominator, but from your fifth grade knowledge, fourth, somewhere in there, 4.5 grade knowledge, what is the common denominator? 15. Okay, so we're going to write up here, least common denominator equals 15. That is not true. Okay. All right. What I like to do is I like to think of this like shopping. This shopping bag has a 3 already, and it needs a 5 to make it 15. This shopping bag has a 5 in it already. It needs a 3 to make it 15. Do you see what I'm doing there? Okay. Shopping fixes everything. No? Okay. Well, that is a opinion that my husband may share as well. Anyway, moving on. So 5 times 1 is 5. 5 times 3 is 15. Plus 2 times 3 is 6. 5 times 3 is 15. The whole point was to get the matching common denominator. Add across the top. Bottom stays the same. All right. There is your fraction review. Okay, now this is a rational expression. Rational expressions mean algebra fraction thingies. And this one, all of problem 27, you're welcome, has a common denominator. Okay, so add across the top. Bottom stays the same. Add across the top. Bottom stays the same. Okay, now we have a problem from yesterday. Now we need to see if this can be reduced. Now, can I cross this out to make that 1/3? No, don't do it. I can, however, do something that starts with an F and ends with actoring. Yes, okay. I want you to, in your groups, please factor the denominator. I have set you up to diamond and box, you guys. Factor the denominator in your groups. Okay, actually, you're going to do 3 things. You're going to factor the denominator. You're going to look for a giant 1 to cross out, and you're going to write the final answer. And I'm going to freeze the screen so you can't cheat. You can talk about it though. I'll give you a hint. One of the factors might be, I don't know, shockingly, 2x plus 7. I wonder where I got that from. All righty. I have no more time to spend. I factored this to 2x plus 7, x minus 3. I found a giant one of 2x plus 7, reduced. There was nothing left on the top, so 1 over x minus 3. How'd we do? What? Oh, 1, yes. Okay, so you have to actually imagine that red line is a 1. That will help you remember that that's a 1 up there. Notice I didn't say anything about excluded values. We are going to do excluded values in number 29. We're not going to do them in 26 and 27 and 28. So don't need to do that. But just a reminder, you would look here, not here for your excluded values. So this would be negative 7 over 2, and this would be positive 3. How are we doing on the excluded values? Okay, so again, on your quiz, it's going to say simplify and state all excluded values. It'll remind you. So, you know, in case you're a person who, like me, just likes to get x equals 5 and move on with my day, forget about those little details. That will be there. You just have to read the directions. So, direction reading, very important. Any questions about A? And you realize A is like an easy one. Do you know why it's an easy one? Same reason that this was an easy one, or this was an easy one. Common denominator already. Okay. Go ahead and write these here. Okay, so B, I'm going to help you get it condensed to one fraction, but then you guys are going to factor on your own again. But for C, we're going to do the whole problem together, the whole thing. C is, it's not spicy. There's just like a couple of details we need to discuss. It might be spicy. You might think it's spicy. But okay, let's work on B. So this one is relatively simple. This is a subtraction problem. So that means I'm going to subtract across the top and the bottom stays the same. Subtract across the top, bottom stays the same. Okay, in your groups, I want you to GCF the top. I want you to diamond and box the bottom unless you can do it in your head. So let me reword that to proper math vocabulary. I want you to factor the top and bottom. But I gave you a hint that the top is GCF and the bottom is diamond and box. I want you to look for a giant one. I want you to cancel and write the final answer. Do you understand the words of which I've spoken? Factor the top, factor the bottom, giant one, cancel, final answer. This is an easier problem to factor, I think. I could do it in my head, but I'm not going to because I'm full of energy this morning. I don't know why you're being so silent. Is it because I won't let you get a word in edgewise? Quick survey. What do you think? And I'm going to need you to hold up one finger or two. Do you think factoring is the most important skill for a Math 2 student coming into Math 3? Hold up one finger if you think it's factoring. Hold up two fingers if you think it's quad formula. Good to know. Okay, what if I said quad formula, including breaking twins out of jail and knowing what to do with I? Okay. Yeah, okay. I kind of created some bias in my own question there. But I feel like I could teach factoring a lot faster than I could teach quadratic formula with breaking twins out of jail and I. What? Thanks, Nolan. All righty, people. Here you go. So the top is 5 parentheses x minus 3. The bottom is x minus 3, x plus 1. X minus 3 is made a giant 1, reduced to 5 over x plus 1. Is anyone willing to tell me the excluded values for this problem? 3 or -1. Beautiful. Okay. Now for C, we're going to do this one together, like together. There's a couple of spicy details in here. I'm going to use a red pen to point out those spicy details. Okay. So subtract across the top. I added one of the spicy details in there already. Okay. Now let's just pause here because this is might be the most important thing about this problem. This subtraction is for both items, subtracting x and subtracting 4. It's not just subtracting x and then adding 4. It's subtracting x and subtracting 4. So you need to make sure that you put that subtraction in parentheses. If you put the parentheses there 9 times out of 10, it'll come out okay. Okay, now the bottom stays the same. Okay. So 2x on the top. Do you see where the 2x came from? Okay. And 9 minus 4 is 5. So that's my first detail. If you had 9 plus 4 there, you would get that wrong. And you'll be able to tell because you want to cancel stuff out. If this was 13 and you factored the bottom and you didn't get a 13, you'd be like, oh, that's weird. Because usually these are reducible. Mrs. Talbot told me most of the time I can reduce them, but this one wasn't. Maybe I made a mistake, say, up in here somewhere. Okay, anyway, now we have another spicy bit. This is a GCF and a difference of squares factoring. So I'm going to do this one with you. Do you notice that it has a GCF of 2? Okay, so 2, 4x squared minus 25. And back when I taught math 2, I said to myself, okay, how do I identify a difference of squares? Is this a perfect square? And I answer that question by making 2 branches and seeing if these 2 things are the same. Is this a perfect square? 2 branches, they're the same. And then is it subtraction? So I'd ask myself 3 questions for difference of squares. Is this a perfect square? Is this a perfect square? And is it subtraction? Okay, so 2 x's go in the front seats. 5's go in the back seats. Plus and minus. Are you shocked by these factors here? Looking at the numerator. You should not be, right? You should feel like you're on the right track. Reduce. Okay, we're not going to talk about excluded values because in number 29, I'm going to ask you to come back and look and find the excluded values for this. Okay. D, last problem with a common denominator. Oh, fun. Do you guys need a minute to write it? Yes? Okay. All right, Mrs. Talbot, it's quite a large fraction bar you have there. I love this problem. Did anybody find the spoiler alert of this problem yet? Anyone? Joel did. Did you find it? Okay, I'm going to do it in 2 steps, but okay, so this is an addition problem. Add across the top, bottom stays the same. Okay, now we're going to combine like terms on the top. So I have x squared plus 2x squared. This is going to be amazing. Wait for it. 5x plus negative 3x. Negative 2 plus negative 6. Oh. No need to diamond a box if it's exactly the same on the top and the bottom. So keep your eyes out for those. It'll save you work and time. So satisfied. Okay, now I need you to take a deep breath because we're going to work on not common denominators. Yeah, there's only 2 of them, and then excluded values, then we're done. Those 2 are not short by any means. Just gonna show you this one for now. Let's just focus on one thing at a time. Also, notice that I started my problem with some space here that is on purpose. Harry's is broken. You don't seem upset by that. Okay. All right. So, common denominator. Okay. This is what I need you to know. 3x plus 1 is a number. It's some number. We don't know what it is, but it's a number. Okay, are you okay with that being a true fact? 3x plus 1 is some number. Let's call it smiley face. Okay, and x minus 5 is a different number. Okay, can you grasp that situation? Okay, now don't write this. Don't write it. Don't write it. I'm going to transport you back to 5th grade for a minute. This is a 5th grade version of this. So, oh crap. There we go. This is a 5th grade version of this. So these are the same number. This is a different number. And these 2 are being multiplied together. Okay, are you with me so far? Okay, what is the common denominator of the post-it problem? 15. Okay, the post-it note problem, the common denominator is 15. What did I do to get that 15? Yeah. Okay, so what does this side need? A 3. Okay, 3x plus 1 is in my shopping bag. What does this side need? X minus 5. Beautiful. Okay, so you're going to multiply by a giant 1 made of the other thing. You already have this thing. You're going to multiply by a giant 1 made of the other thing. Okay. Now, you guys know we add across the top, bottom stays the same, right? So we're going to go x minus 5 times x plus 2x squared minus 2. And then the bottom stays the same. I want you guys to know that it's already factored. So don't mess with it. Don't like box this out or anything. It's already factored. So leave it. It's like your job is already done for you. Okay. Before I move on, there are some of you, and this is going to happen on the test. I don't know what to do about it other than just to try to warn you ahead of time, but it's still going to happen, that are going to cancel that thing that you just put there. For some reason, you'll do this, you'll write this, and you'll cancel that. And you can't cancel that because there's a giant plus sign right here. Also, that would be really ridiculous because it's just getting you back to the original problem where you multiplied this on. Bless your hearts. So it would be sort of like undoing the thing that you just did to get the common denominator. I don't know what I could possibly say to make that not happen other than what I've said, because I said the thing about the exponents on the binomial expansion like 50 times and it still happened. So I don't know. We're just going to do our best. Okay, anyway, over here, we're going to distribute. The x is on the right. It's okay. X times x is x squared minus 5x plus 2x squared minus 2. Okay, let's combine like terms on the top. 3x squared minus 5x minus 2. Okay, does anyone want to venture a guess about what the next step is in this problem? Factoring. Okay, beautiful job. I want you to, in your groups, factor the numerator, please. I'm just going to draw the setup here, but if nothing else, you notice the giant amount of space that I left below the problem. So guys are just silently factoring. Yeah. Okay, take your time. guys. Day 74. We're almost there. Oh, you don't even have me tomorrow. You'll be, you won't even have to bother with it. Your last, maybe. Maybe I'll keep the water thing going. I don't know. I can't decide. It would be, but the bathroom investigations are complicated, especially with this job. Like a Homer bucket with a seat on the top, like when you're camping. What? You do if you have to go in the middle of the night and it's creepy out there. Oh, you mean just go in a bush? Why are we talking about this? Okay, anyway. Oh, yeah. You're a much better camper than I am, 100%. If I had to choose anybody in this room to camp with, it would be you. I am not a camper. What? He's gonna be an Eagle Scout. Like
she is a scout too. She will be.
Whoa!
You got dose.
Well, then it'll be three of us, and I could just like limp along. Anyway, we were just discussing camping.
Or glamping.
Oh, see, this man knows it. That's right. Don't do this again. Okay, so let's go over. I factored the denominator. No, lies. I factored the numerator to 3x plus 1 x minus 2. I was not shocked to see the 3x plus 1. As a matter of fact, that validated me. I reduced the 3x plus 1. Was I at all nervous about the fact that they were diagonal from each other? No. Still made a lovely diagonal looking 1. And then I reduced to x minus 2 over x minus 5. How we doing? Okay, we have Una Moss, and then number 29 is quick. 29 is just excluded values only. Okay. Last one. Let me keep it there for anyone that got stuck. Okay. All right. X plus 3 is a number. X minus 3 is a number. X plus 3 is the same number as this number. What does it need? It has an X plus 3 already. What does it need? An X minus 3. Okay, so I'm going to multiply by a giant 1 made of X minus 3. And then hopefully you can see, oh, now the denominators match each other. Okay. Equals giant line 9 minus 3x plus 2x x minus 3 over x plus 3 x minus 3. Okay, how are you guys with this to here? So figuring this out, there's a missing an x minus 3, multiply by a giant 1, and then adding across the top, bottom stays the same. Okay, now we're going to go distributive here. 9 minus 3x plus 2x squared minus 6x and then I'm going to combine like terms on the top, and I'm going to rearrange it so that it's in descending order. Do you know what I mean by descending order? So like x squared, then x, then number, so that it's for the factoring. So I have 2x squared minus 9x plus 9. Okay, do you know what I'm gonna ask you to do next? Factoring. Okay, so you're gonna factor the numerator. Look for giant ones. Cancel. Write your final answer. I know the theme of the day is common denominators, but I feel like the theme actually might be factoring. Common denominator. Factoring. That's a different thing. You have to ask the right questions. Okay. All right. So I got 2x minus 3, x minus 3 for my factoring. Made a giant one out of the x minus 3s. And then 2x minus 3 over x plus 3 was my final answer. Any questions about B before we move on? Did you do it? You did get it? Okay. Last problem of the day is it's all about excluded values. So if you guys could write this down. These do not need to be spaced apart this much. Honestly, they only really need one line. For those of you over in the southwest corner that are saving notebook space, that will be remain unnamed. Okay, I want you to do this in your groups also. But let me tell you what I want you to do. I want you to look back at these three problems. So 27C, 28A, 28B, and I want you to just list the excluded values for those problems. So talk about them in your group. Should take like 2 minutes tops. All you're doing is flipping back to those problems, those three problems, and stating the excluded values. What? Yeah. Yeah. Guys have 60 more seconds. Okay, hold on. Here we go. Take a look, please. The first one is -5/2 and +5/2. Negative and positive. The second one is 5 and -1/3. And the third one is -3 and positive. Yes, sir. Because there were both in the denominator. Hold on, let me flip back for you. You see? So right here, this is the -5/2 and this is the +5/2. So you remember, you always have to get your excluded values from the problem, not the answer. Always from the problem, not the answer. Right, you guys have like time to do homework.